So this question says Mr. Antonite, I'm not really sure how to pronounce his name, but that guy is on break duty and is monitoring social distances of students on a field below. He looks down at Mazizi and Cameron from the first floor corridor, who are on the ground looking up at him. The angle of elevation of Mazizi to Mr. that guy is 90 minus 2 theta. Now they tell us here that AM is K meters, GC is 8 meters, MGC is angle MGC is 150 degrees and angle MCG is theta. So the first question here asks us to get the size of MAG in terms of theta. Now before we do all this, right, because this is 3D trig, I'll recommend you redraw this as a right angle triangle that it is. So what we do understand is that this is K, this is angle A, angle M, angle G, and that's 90 degrees over there. And we're told here that this is 90 minus 2 theta. So the question is asking us to find what this is. You understand that if this is 90 and this is 90 minus 2 theta, we could just say that angle MAG would be 2 theta. Okay, so we have that there as 2 theta. Okay, so reason, sum of angles in a triangle. The next question says show that MG is equals to K sine 2 theta. Okay, so now we are trying to find this one over here. Now that we've actually found this angle here to be 2 theta, I could say that to find this, I can look at MG is opposite of A, and since it's a right angle triangle, we can use SOHCAHTOA, right? This is my opposite, that's my hypotenuse, so I could use sine. I could write this. I could say sine 2 theta is equals to mg over k, and therefore we understand that mg will just be k sine 2 theta, and that's exactly what they wanted. That's it. So question C says show that MC is equals to K cos theta. Okay, so first and foremost, in the previous question, right, the previous question we got MG to be K sine 2 theta. Now because we do have this, we understand we have an angle side pair, and we're actually trying to find this one over here, right? This is the unknown. Okay, so we would use sine rule, and sine rule would say that sine theta over K sine 2 theta is equals to, we have sine 150 over MC. Sine 150 over MC. Okay, to find MC, the first thing we'll do here is cross multiply. Now sine 150 can be reduced into sine 30, right? Because it's in the second quadrant. So since sine 150 gives you sine 30, which is equal to half, I understand that this here will be K times, that is double angle identity. So this can be rewritten as 2 sine theta cos theta. Okay, so this is 2 times sine theta cos theta. All this over sine theta. Yeah. So as you can see over here, sine theta can cancel sine theta out. This 2 here can cancel that 2 out. So all you're left with is this and that. And that's your answer, which is K cos theta, which is equals to MC. And as you can see, that's exactly what they wanted. And that's it. Now D says show that the area of triangle MGC can be written as 2K sine 2 theta. Since it is not a right angle triangle, the formula for area can be calculated using area rule, right? And the formula kind of looks something like this. You can say the area is equals to half AB sine of capital C, something like this, right? Okay, so it always has to be an included angle. Right, so I'm looking for an included angle to help me get my answer. I'm looking at this here. I could look at an included angle in terms of MG and GC because I have 150. I could also look at the included angle as GC and MC because I have theta. I could try to figure this out, but I think it would be more complicated. So the easiest way I think I could do is just look at MG and GC. So taking K sine 2 theta, taking this as 8, taking this as 150. So I'm going to say half times 8 times K sine 2 theta, the sine of 150. Okay, so this here can be written as half times 8 K sine 2 theta, right? Because this whole thing here gives you half. Because remember, it gives you sine 30, which also gives you half. So half times half is 1 over 4. 1 over 4 times 8 is 2. So I just have 2 K sine 2 theta, which is exactly what these guys wanted. That's it. That's your area. Well done.